Reinforcement learning with explicit human values. Crazy new paper. The idea is that learning to answer some questions right is a lot more beneficial for the model than other questions that are not so beneficial. So humans are gonna label some questions as more valuable. So the issue with previous methods, as the paper claims, like reinforcement learning from verifiable rewards, where the model gets a question and then its answer is checked. For example, if it's a math question, we already know the correct answer, so we check the model's answer against the correct answer, and we reward by +1 if it's correct, and we punish or we don't reward the model at all with 0 reward if the answer is wrong. The limitation of this is that whether model answers difficult and important and valuable question correctly, that's valuable to know in the real world, or some trivial question that's not so valuable, it's gonna get the same reward. So it's not more rewarded more for knowing more valuable answers and how to solve more valuable problems in the real world. So in this paper's method, they have a bit different design. So human creates this data set of questions, and they call it maybe exam. And there is a maximum score. If all questions are correctly answered, then maximum score, let's say 150 points. But each question has its own points, depending on the value of the questions. So more valuable questions give more points. For example, we have a question about physics from physics, and we also have the ground truth and how many points, which is human defined, this question gives. Here are more examples. What is the capital of France? Paris is the ground truth, and let's say this score is just 2, and the total score for this set of questions is 100. Second question has score of 10, and then third has score of 4. For example, there is more questions, so that all of their scores add up to 100 maximum. Now let's see if the model answers a question correctly, how much reward does it get? So let's take an example, this second question, explain the process of photosynthesis, that gives 10 points. It's a high value question. So first, we will calculate normalized human value. It's just, we divide the points it gives with the total points to get kind of percentage. So that's normalized human value. So this can be like 10% or 0.1, whatever. But this will just push our score between 0 and 1. And that's good in LLMs or neural networks. They like numbers between 0 and 1. Then we avoid a lot of issues like exploding gradients, but that's not important. So normalized human value is 0.1 here. Also, we must normalize because we don't want the reward to depend on arbitrary choice of the scale of the rewards. What that means is, imagine one person gives scores from 1 to 10, and the other person gives scores from 1 to 1000. So now, this person that gives scores from 1 to 1000, even though the questions are not more difficult, it's just the scale is now bigger, so the reward will be bigger. So we don't want the scale of the numbers to influence our reward. So we want to put all of the numbers, all of the scores into the same scale between 0 and 1. Putting it between 0 and 1 solved the first problem of scale, but just giving this reward, 0.02, that's a very small reward for the model. So we actually need to increase this reward. We need to somehow scale it up a little bit. If you are confused now, why are we first scaling everything down and then scaling it back up? Remember that in the beginning, every question set has a different scale of the rewards. So this question set might give 15 points for difficult questions, and this question set might give 15 points for easy questions. Because maybe this one is scoring from 1 to 20 and this one is scoring from 1 to 100. So we want to actually put a relative scale, all same relative scales. So easy questions get like 0.1, 0.2, 0.3, and then difficult questions get higher than that. and they are all at the same scale. Okay, but as I explained, these are very small numbers for reinforcement learning. So in reinforcement learning, we want to give a bit bigger numbers than this, maybe around 1 or something like that, as the reward. So the reward formula goes like this. We got, if the answer is correct, 1, or incorrect, 0, and then s of x is how much reward we get. So you see that if the answer is correct, we will get s of x reward because it's times 1, and if it's incorrect, we will get 0. And s of x will be reward based on how important the question is. What percentage of final score for that test dataset it carries. So for low value questions, it can be 1.2. For high value questions, it can be 2, for example. So how do we bring from our 0.01 normalized to this a bit higher, around 1, 2 reward, because we need a bit higher rewards for reinforcement learning for it to work. This is the formula. 1 plus minimum between number 1 and some hyperparameter that we predetermine that I will explain, times the human normalized value. So I'm going to explain step by step all of this. First, let's look at this v of x, which is our human normalized value that I was just explaining. It's dividing the score for the question with maximum score for the entire set of questions. So for easy question, it can be 0.02. For difficult and valuable, I should say valuable question and less valuable. So for valuable question, it's going to be 0.1. And it's going to be between 0 and 1 always. So if we go back, this alpha hyperparameter, as I said, this is a very small number for reinforcement learning. We want bigger numbers. So that alpha will just multiply this number, for example, with 10, which they use in paper, just to make it a bigger number, because that's what reinforcement learning needs. So alpha is equal to 10. So this will become 1, this will become 0.2 when we multiply it with 10. And then we also have this minimum, which is like a clipping function, because we don't want the reward to be too high either. So we will actually, if this is higher than 1, alpha times our human value, we will just make it 1. So we don't want this to be above 1. So 1 is the maximum. So this value here will be the smaller number between 1 and our scaled human value. So this number can be between almost 0 and 1. If this human value is very, very small, 0.001, then multiplying with 10, it's still going to be very small. It's going to be like 0.01 or something. It's very small. So this value will then be that very small value, because it takes the smaller value. So this number here, as I said, can be between almost 0 and 1. And then we will just add that number to 1, and that's going to be our score, our reward, if we get if the LLM gets the correct answer correct. This 1 plus is just for the sake of reinforcement learning, because I said that we don't want too small values in reinforcement learning. So this is going to make it between 1 and 2. Because this is between 0 and 1, so 1 plus this is going to make it between 1 and 2. And those are good values for reinforcement learning. So if the question is less valuable, the model will get score around 1 if it answers correctly. If the question is more valuable, the model will get score approaching 2 or 2 if it answers correctly for the more valuable questions. You see here, for easy or less valuable question, as determined by the humans, it can get 1.2 points if it answers correctly, but for a more valuable question, it can get up to 2 points if it answers correctly. That will be it for this video. Join my school to become AI researcher. You have all of these courses linked below. It's gonna be free for a bit more, and then I'm gonna make it paid. So hurry up.